In the far future, every wheel will have its own motor. The output will be better and motor control will be enhanced. Will lubricants still be used then? They will definitely be used for.
Subscribe to LiSTA Lubricant Labs, like the video, and turn on notifications.
Dr. Kim, it would be great if you could also cover electric vehicle reduction gear oil and insulating oil. I've been waiting for reduction gear oil content. Please tell me about reduction gear oil. These are some of the comments we've received.
The era of electric cars has arrived. People always ask me, expressing their concerns. They worry about what I'll do now that there's no engine. Since I make engine oil, they are concerned about me. But actually, the world of lubricants is endless. Electric vehicles use a type of lubricant called reduction gear oil. So what's a reduction gear? Just like the name says, it slows things down. Electric vehicles have a motor instead of an engine. The power generated by the motor must be transmitted to the wheels. So instead of a transmission, there is a reducer gear. A reducer gear is what does this job. A car's engine burns fuel and the output changes depending on how quickly the RPM is increased through the compression ratio, right? A motor produces its maximum torque right from the start, a full torque. Electric cars accelerate really fast. They can hit full speed in just 3 or 4 seconds over 100 meters. The torque shoots up and the RPM spins incredibly fast. Then the torque starts to drop steadily. A drop in torque means a decrease in output. It means the output decreases when running at high RPM. What's the solution to this? Just like shifting gears, the torque is transformed through gear shifting. It's slowing down and increasing the torque. So basically, the motor spins at high RPM, but through the gears, the speed is lowered and torque is increased. That's why it's called a reducer gear. So, does a motor always have to run at full torque? Does it always have to run at maximum RPM? Not at all. Speed is managed directly by the motor. However, with the speed adjusted by the motor, you can produce the desired output or torque. One of the 2 gears, one big and one small, is to adjust the gear. That's what makes it efficient. For the gears to turn smoothly, there's got to be lubricating oil. The lubricant used here is reduction gear oil. If we're talking about a transmission, it's transmission fluid. In other words, a lubricant is used. It's gear oil, not fluid. It's for real moving gears. The gears are turning, it needs lubricity. For gears to turn, friction doesn't have to be necessarily reduced. A certain amount of friction is needed for the gears to mesh and turn. The motor spins at an incredibly high RPM. This generates an enormous amount of heat, so it has to be cooled. In the past, air cooling was used. Lines were installed inside the motor, or devices were attached to the outer wall to cool it with water, alcohol, or other substances. This made the systems too complex. And air cooling was less efficient. Thinking about what to do, they adopted a method of cooling the motor with oil by spraying or submerging it. They adopted a method of cooling it with oil. This is what we call motor cooling oil. Motor cooling oil has different requirements. The coil is made of copper. Copper should not be corroded. It must prevent corrosion. Since it runs on electricity, it must be insulating. Originally, there was a separate reducer oil. Motor cooling oil should also be separate, but it's too inconvenient to carry them separately. So how's that coming along lately? They're combining them. A single fluid is being developed that works as a reducer oil and a motor cooling oil. Reducer oil must have lubricity and friction control. Since it has to last a long time, oxidation stability must also be enhanced. As I mentioned, motor cooling oil must be insulating. It must not corrode the copper coils. It also needs to cool heat quickly. How do you think it turns out when they try to combine two? It will be incredibly difficult. This is truly an art. Many large corporations are struggling with this. Right now, companies like Tesla and other EV manufacturers are using ATF or MTF, either slightly modified or as is, for their reduction gear oil. And that's how they are using it. These conditions have been sufficient until now. But when it needs to handle motor cooling as well, then the conditions become even more severe. Engage and rotate precisely. What if the gears don't turn? I'm seriously considering taking on this challenge myself. In the distant future, every wheel will have a motor. The output will be better and motor control will be enhanced. It's going to be controlled by AI, right? Will lubricants still be used here as motors get smaller? Special grease will definitely be used. Lubricants can also be used inside the motor, as I said, for cooling. Another thing is that an EV's huge battery is located on the bottom. This generates a tremendous amount of heat. It needs coolant as well. It's called a coolant. But it's completely different from the coolant used in regular cars. Why? Because it has to cool the battery. Electricity is flowing through it. It must be insulating. And since it has to pass through the gaps, it's not oil but a coolant. It has to be an alcohol or other water-based coolant, but water conducts electricity. So, various research is being conducted on this.
Can I put the differential oil from a rear-wheel drive internal combustion engine vehicle into an EV reducer?
As I mentioned, ATF or MTF is used as reduction gear oil. A common differential oil used recently contains MTF. The low viscosity one is used. So what you are saying is correct. Currently, it is okay to use it. The oil used here is low viscosity, around 75W or 70W. And since it has to last a long time, it's made with PAO or a 50-50 mix. They use those made with high-quality synthetic oils. Of course, there are also Group 3 oils for differential oil. Those have a shorter lifespan. The new reduction gear oil must have motor cooling oil functionality. They must have various functions. So you shouldn't use differential oil here.
I'm also curious about the grades and certification standards for the oil used in EV motor reducers. That was the question.
For EV reduction gear oil, the grades are currently set by each company. They're going to make the reducer, right? Whether a car company makes it or gets it made elsewhere, they conduct performance tests to match it. That's how they create their own specifications. And they follow them. In Tesla's case, they have something called KAF. When I went to a conference last year, they said they were developing KAF2. Those things are constantly being developed. Car companies and reducer companies take ATF or MTF and test it. After it passes their specifications, the name changes to reduction gear oil. For engine oil, there are national or OEM specifications. Reduction gear oil technically needs to be changed, but it's often marketed as lifetime or no replacement needed. It's put in as a factory fill when the car is made, and then it's not replaced. So there's no profit to be made. This isn't something consumers buy and use. If a company has specifications, the oil is made to fit those specifications. It's made for factory fill, so that's all that's needed. There's no reason to create national standards or anything like that. The market is small, so each company has its own specifications. They are still conducting tests, but in the future, it has to be combined with motor cooling oil. These are the challenges. I'm going to try to make one. I'll make one and go to Hyundai Motor and tell them to test it. If necessary, I might go to Chinese car companies as well. Many companies are making them now, Mercedes, BMW. I might test it there too. But there's still so much to do. Please wait a little longer.